Discuss our next question, that is median in arrow y shorted matrix. So first we will read the question, after that we will try to solve this question, right? So given a row y shorted matrix of size R cross C where R and C are always odd, find the median of the matrix. So we have given a matrix of size R cross C where R is the number of rows and C is the number of columns, and R and C are always odd, means the number of rows and number of column will be always odd, and the element in the matrix will be number of element in the matrix will be odd, right? So how we can solve this question? We have to find the median of this matrix, right? So rows are sorted in increasing order. So this is our example, right? So what will be our brute force approach? How we can solve this question? So this is our example. Let's discuss it on the board. So we have given this is example. So what we can do, we can store these elements in an array, right? So we will take an array in which we will store all these elements. After storing this element, we can sort the element, we can sort the array, right? After sorting, what we get, 1 2 3 3 5 6 6 9 9. So this will be our array after sorting and inserting all the element of the matrix in this array, and we sort that array, right? This will become our array, look like this. So what will be our medians? Our median will be the middle element of the array, because number of element in the array are odd. So middle element will be the median. So in this case, what will be the size of the array? It will be 9, right? So 9 by 2 will be fourth, means the element at fourth index, means fifth element will be our median, right? This is index 0, this is index 1, this is index 2, this is index 3, and this is index 4. So this is our median, and it is fifth element. It is fifth element. Okay, so what will be the time complexity of this? This is our code, and we discuss about the time complexity. This is the code to store all the element of the matrix in this array. So its time complexity will be R cross C. R cross C will be the time complexity, right? So after that we are sorting this array, right? After inserting all the element of the matrix in array, we are sorting this array, and the time complexity of this array will be R cross C into log R cross C. R cross C into log of R cross C. Log of RC. This will be our time complexity, and it will give TLE surely. And to return this element, its time complexity is order of 1 only, right? ये जो हमने अप्रोच डिस्कस की है उसकी टाइम कॉम्प्लेक्सिटी बहुत ज़्यादा है, जो कि है आर क्रॉस सी log of RC, right? So and we are using extra space of R cross C, right? So now we have to optimize our solution, right? How we can optimize? We have given shorted rows, right? So when we are given shorted, we can think about the binary search, right? So in this case, we have given a range of the element, that is 1 to 2000. The element can be lie between the 1 to 2000 range, right? And here is the example. So here what we can do, we will take we will understand, first we will understand what is a median. Median is the element it is a point, the number of element before that point is equal to the number of element after that point. Means the number of element which is smaller than the medium is equal to the number of element which is the greater than the medium. That is this is the property of medium, and we will use that property here. And how we can solve this question, uh, how we can solve this question, we will take this example. And here we have 9 element, right? And we want 4 element, which we have 9 element. One element will be the median, and the 4 element will be smaller than the median, and the 4 element will be greater than the median, right? So we need 4 element which are smaller than the median, right? So how we can solve this, we will use two pointer, low and high. So low will be the pointing the lowest number, lowest integer, uh, yeah, we can say lowest element in the array. And the high will represent the highest number or highest element in the array, right? So this is the right. And we will calculate the mid. We will use this formula to calculate the mid, and we will apply a while low is less than equals to high. We will calculating low, and we are changing low, we are calculating mid and changing high and low according to the condition, right? What is the condition? Condition is that when we need actually 4 elements which are smaller than the median, right? If we get larger number of elements which are smaller than the median, in that case we will change the high by mid minus 1, and else the element which are smaller or greater equal to the actual number, in that case we will change our low by mid plus 1. This is our condition, right? So we will discuss the code. After that we will dry run that code, okay? The code, this is our code, and in the code we will take two pointer, low and high. Low will pointing to the one, and high is the pointing to the highest element, right? And mid is the median which we are calculating, right? And actual count will be the number of smaller element we want, right? And we apply a while low is less than equals to high, and initially our count is 0, right? Initially smaller element, the element which are smaller than mid, initially we assuming 0. And after that we are applying a while loop, for loop on the number of rows, and for each row we are calculating the count using solve function and using binary search, because rows are given in sorted order, so we can use here binary search, okay? And after calculating the count, what we are doing, we are checking the condition, count is less than equals to actual count. If the count number of smaller element which are smaller than mid is less than equals to actual what we want, if that are less than that, in that case what we are doing, we are changing low by mid plus 1. Otherwise, if the count is greater than the actual count, in that case we are changing high by mid minus 1. And at the end we are returning the low, right? So in this example we have 9 elements, okay? And n is the 9, and we want 4 elements which are smaller than the median, right? And for the element which are higher than the median. So initially low and high are 1, and this is mid. So here I solve this. Initially mid is initially mid will become 1001, right? And we will calculate the number of elements which are smaller than 1001. All the elements are smaller than the 1001. In that case we are changing our high by mid minus 1. Now our high will become 4, our high will become 1000, and our low will remain 1, right? And after that we are calculating again our mid, and now our mid is 500, right? And now we again check the number of elements which are smaller than the 500, right? All the elements are smaller than 500. Now we will again change our high to mid minus 1, that is 499, and our low will remain same. right? And we again calculate our mid, that is 250, right? We will check again the number of elements which are smaller than 250. All the elements, in this case all the elements are smaller than 250. We will again change our height to 250 minus 1, that is 249, right? And we will again calculate our mid, it will become 125. And now we will again change our high to mid minus 1, that is 124, and our high will become 124. And we will calculate the number of elements which are smaller than we will calculate the mid, and it will become 62. And we will check again the element which are smaller than mid. All the elements in this case are smaller than mid, and then we will again change our high to mid minus 1. Now it will become 61, right? And we will again calculate our mid, and now our mid will become getting our mid. In this case it's written by mistake, it will be 31, right? Our mid will become 31, right? And we will again check the number of elements which are smaller than 31. In that case there are all the elements are smaller than 31, and we will again change our high to mid minus 1. Now in that case our high will become 30 minus 31 minus 1, right? And after that we are changing our high, and it will become uh, after that we will again calculate our mid, and it will be 16, right? And after that we will check the number of elements which are smaller than the mid, right? All the elements are smaller than mid. We will again change our high to mid minus 1. Our mid was 16 and high will be 16 minus 1, that is 15, right? And we will again calculate the mid, and in that case our mid will be 8. And we will calculate the number of elements which are smaller than the 8, so, right? So we have 7 elements which are smaller than 8, right? We have 7 elements which are smaller than 8, but we want only 4 elements which are smaller than the median, right? So in this case we will again change our high to mid minus 1. In that case our high will become 7 and our low will remain same, and we will again calculate our mid, and in that case our mid will be 4. Now we will calculate the number of elements which are smaller than 4. So we have 1, 2, 3 and 4 elements which are smaller than 4. So number of element which are smaller than the actual element is equal. Now we will change our log by mid plus 1. So here our mid will become 5 and our high will become 7, and we will calculate our mid again, and it will become 6. And we will check the number of elements which are smaller than 6. We have 5 elements which are smaller than 6. So we will change our high because 5 is greater than 4, right? So we will change our high, and it will our high will become 5, right? And we will again calculate our mid, that is 5, right? And the number of elements which are smaller than the 5 are 4, right? We will change again our low by mid plus 1, and in this case our low will become 6, but our condition was while low is less than equals to high, right? So we will return our previous low, that is 5, and that was our answer. Okay, and this is our code. And the time complex while loop, uh, the time complexity of while loop is log of 2001, right? And base 2, okay. And this for loop is the time complexity of this for loop is r into, we are using binary search for n columns, right? We have n columns in a row, right? So it will be log c, right? And this is our time complexity, and we are not using extra space. So this is our better approach than the previous. Thank you guys.